Welcome back. We're solving inequalities much the same way that we solve equations. We're basically using basic arithmetic to isolate our variable to one side and get everything else on the other side. So let's look at a few more examples. Let's say we have the inequality x plus 5 is greater than 1. So if this was an equation, if this greater than sign was actually an equal sign, how would we solve for x? All we do is simply move 5 to the other side, and we have x by itself, and we have everything else on the right. So what we would do is we'd subtract 5 from both sides. These two terms would cancel, and we'd have x equals 1 minus 5, which is minus 4, but in this case, we just have a greater than instead of an equal sign. So we have x is greater than minus 4, and that's all there is to it. So we're treating inequalities the same way we would if this was an equation. So let's look at x plus 2 is greater than minus 4. Okay, so how do we solve for this? Well, we basically want to find x, so we move everything else to the right side. We do this by subtracting both sides by minus 2. These two terms would cancel, so we have x is greater than minus 4. Let's look at another one. We're solving inequalities using basic subtraction. Let's do a few more just for practice. So we have x plus 9 is less than or equal to 7. Less than or equal to 7. That's a funky looking 7, so let me go ahead and rewrite this. X plus 9 is less than or equal to 7. All we do is isolate our variable by subtracting 9 from both sides, leaving us with just x on the left side, our less than or equal to sign, and 7 minus 9 is minus 2, and so our answer is x is less than or equal to minus 2. Let's look at a few more. Let's say we're given the inequality x plus 11 is less than 3. We simply subtract 11 from both sides. These two terms will cancel, leaving just x on the left-hand side and less than, oh, my computer's freaking out. 3 minus 11 is a minus 8. So all the values in our interval that satisfy this inequality relationship need to be less than minus 8, but we're not including minus 8 in our interval. Let's look at x plus 1/2 is greater than or equal to 3/2. All right, don't get excited since we're using fractions here. Everything will work out just the same. We need to isolate our variable, getting everything else on the other side. So we subtract 1/2 from both sides. These two terms will cancel, leaving just x on the left-hand side. X is greater than or equal to 3/2 minus 1/2 give us 2/2, which is the same as x is greater than or equal to 1. All right, we can actually leave it in both forms since we're dealing with rational numbers. There might be certain situations where leaving it in fraction form is more useful. So both these forms will work, but we're simply using basic subtraction to isolate our variable just like we would if this was an equation. All right, let's look at one more. Let's look at, just for practice, we have x plus 3 is less than or equal to minus 14. Minus 14. Okay, so we isolate our variable by subtracting 3 from both sides. These two terms cancel, leaving us with x on the left-hand side. X is less than or equal to minus 14, and minus 3 is a minus 17. So all the values in our solution set are less than or equal to minus 17. So all the values from minus 17 off into negative infinity will satisfy this relationship. All right, so we're solving inequalities just using basic arithmetic. In this case, anytime we're adding something to our variable, we can isolate our variable just like we would in any old equation by subtracting that value from both sides. And that gives us our solution. So in the next section, we'll be solving our inequalities using multiplication, and then we'll look at what happens when we solve our inequalities by using division. So I'll see you soon.